So we've been discussing a little bit about AI and data. And one thing I'd love to talk about is the myths around AI. And like everything we see in the news is kind of like AI is going to take over your job. AI is taking over this. AI is doing this. And I'd love to hear your thoughts behind that. And anything you also have seen in the news where you're like, yeah, that's so wrong.
No, and I think that's hard. That's a good question. It's hard in a very evolving field, right? But I think if we start off with just the fundamentals of what is it, right? How does this even work, right? It's a black box for so many people. And so if we take a step back, one of the ways I always think about it is like, it's called, I think, a Gallatin board. So in essence, it's this board with all these pins on it. It's like a pyramid. It has all these little nails on it. And you drop a ball and the ball bounces through the board. So, and if you do this, right, it is often used to show like a statistical distribution. Because if you put 50 balls on it and they all fall down, they all have a 50-50 chance to go left and right. In the end of the day, what you have is you have this curve, a bell curve, like a standard, distribution curve. And I use that to think of how large language models work. So in essence, your prompt, the question you're asking, it's like the ball. It drops in and it goes left or right. And when we talk about fine-tuning and training, we're talking about weights and how we adjust, they're going to the left or going to the right a little bit. And so maybe, for the first nail it hits, I want it to go right at a 30% chance and, left at a 70% chance. The next one, I want to go, and you apply all these different weights, and it's not just two-dimensional, it's actually, hundreds of dimensions. So we can't really think about it anymore as a human brain. But that's in essence how the decisions are then made of what is the most likely response to the prompt. It's a machine, and the prompt drops through the machine. And, the engineers that build it, they controlled if it goes left and right. In the unsupervised learning models, we don't go as detailed anymore as fine-tuning every variable in there. It's like 500 billion of these nails in essence that the ball drops on and it goes left or right. So it's not really humanly possible to control all of them, or at least it wouldn't create a very good outcome. So we have these unsupervised learning models, but we check on the outcome, right? We check if it got better or not. And we, in essence, run the same tests, millions of times to really fine-tune it. One of the most common training ways of how we train the large language models is you take like Wikipedia and you remove every third word. And then you run it through the machine to say, hey, autocomplete every third word. And it got pretty good at that. And then we said, okay, let's take away every other paragraph. Or maybe first every other sentence, and you autocomplete the sentences, and then you autocomplete the paragraphs. And after a while, the machine knows pretty good, like what it should put in there. But it's always trained on how humans would have done it. And it's always trained on pre-existing data sets. And that's like, it's dependent on us providing good data. So in the history of humankind, right, we would have never been able to build this AI because we never had so much data easily available. Like this is now, the last couple years, we have been putting so much data accessible to everybody, or to the, in the internet or digitally accessible. And now we're able to train these massive data sets, these massive LLMs on massive data sets. So I think that's a super important thing to understand, that that's what it is. It's not a black box. It's a black box in a sense that nobody can fully understand all 500 billion, decisions are like variable hits.
But so if you're not able to understand all these 500 different variable hits, but isn't sort of your code kind of giving you the parameters and of like exactly what it should do? So shouldn't you have an idea of what it should do?
No, and that's the thing. It's so crazy. Like you ask the same question 600 times and you get different outcomes almost every single time, right? Because imagine this ball falling through the board, right? Like if you drop 50 balls that are all the same, you in the end have this distribution. Like they're all over the place. Like if you take one specific ball and you want to see where it landed, it might land over here. It might land over there. Most likely it's going to be somewhere in the middle. right? So I can't predict where the ball is going to go because each time it hits one of the decision points, there's a 30% chance it goes this way. There's a 70% chance it goes that way. So I'm 70% sure it goes this way. But if I ask 100 times, I have 30 balls going the other way because there's a 30% chance it goes the other way, right? So the reason it's built this way is so it can handle many, many different questions, right? Like in the old school of engineering, you only had one path, and you knew that a ball drops in, it always comes out right there. And that works really well for very rigid use cases, very specific things where you always want it done the same way. Like imagine a machine that builds a screw, right? You always want the screw to be exactly the same way. But this tool, generative AI, large language models, was built to take fuzzy inputs, like all kinds of different inputs. And the reason it can do it is because it wasn't built in a rigid way. It was built in a kind of fluid way. And so now you can throw all kinds of inputs in. Downside, you get all kinds of outputs out, right? So one way you control this is called the temperature. So the temperature says, I want you to go wide or I want you to go narrow in what comes out of this. Going wide means that the large language model might come up with some very creative ideas, very like kind of out there ideas. Going very narrow means like, okay, it's probably going to be pretty cookie cutter kind of answer. It's kind of similar to a person, if you hire someone who is like, they're trained in this one way of thinking, like that's a very, kind of expect what the answer will be, versus someone who, maybe they're a more liberal arts education, they come up with all kinds of ideas. Yeah, so it depends on what you want.
So can you go a little bit more into the temperature? What is, like, I understand what you're saying, wide, and like kind of giving the large language model more freedom to make a decision versus being really strict and rigid. What is temperature? Can you explain that a little bit more, please?
Yeah. So let's take an example, a very simple example. An autocomplete, right? Like an autocomplete is, we all know it, right? You start, now we all know it, right? 10 years ago or 15 years ago, it was kind of like magic. Like I typed in, see you later, right? Or, so the next, what is the next likely word? Okay, see you. After see you, what is the most likely word to come? Later, right? And if you know American English, then later is the most likely word to come. If you go with a wider temperature, it would come up with some like more creative ideas of how it could be completed. Like see you later, alligator. And like the alligator edition is like a more creative thing to add to it, a little bit more out there. And the large language model calculates what is the most likely response that you want to hear. So it does some math on like, every single time it hits one of those nail pins in our skeleton board, right? There's a total percentage, like the outcome that you get at the end, right? Let's say it gives it a 3% chance that this is the correct answer. And, it has 16 other versions, maybe even more. And it gives each one a percentage of what it thinks, how likely it is that that's what you want to hear. And then it gives you the one that it feels very comfortable with. With a high temperature, it goes out there and comes up with some like, yeah, see you later, alligator, a little bit more out there kind of ideas. Some of the UIs, like when Google Bard came out and the UI for Bard, which is now branded as Gemini, you could see the different drafts. And I thought it was kind of a neat thing to do. And it's a good educational tool.
The user could see all the different drafts that the AI was, or the large language model was making.
Yeah. So it would give you 3. And it will give you the 3 most likely one. And first of all, I think that's a really good way to use user feedback. Like, oh, you know what? I actually want to hear this one. And, that way we can train the model a little bit better on that. But it also, I think, shows me as a human that, there are different answers. There's not one correct answer, right? There's like 3 things that are highly likely to be the correct answer. And so, one thing a lot of people get frustrated with is like, wait, the AI just lied to me. Like, it was wrong. Like, how can it lie to me? It's like, no, the AI predicted that you wanted to hear A, B, and C. Like, here's a good example. So we implemented this internally, and then our sales team used this tool. Well, actually, I tried it out, and I just imagined what the sales team would be doing. So you ask the tool, how much revenue did we make last quarter, right? And then based on the information the AI has, it predicts what you want to hear, right? That's very different from a calculator. Like when you ask a calculator, what is 4 times 5? It says 20. It doesn't run through calculations to figure out what you probably want to hear. It just does math, right? It's a very straightforward, purpose-built tool. Generative AI, however, it doesn't necessarily do the math. It thinks about what do you want to hear. And so, there are a couple of things you can do to make it more accurate. One is like, hey, show me the steps that you're going to take, right? Like, so let's say, like you're at a mid-sized company and you have the AI connected to your internal documentation and spreadsheets, and you ask it, how much revenue did we make last quarter? Right? The AI probably knows that you're usually around, like, let's say $10 million. Right? Just making up a number here. So now it would go and just predict that that's probably what you want to hear. Like, it doesn't necessarily do the math for you. Like, we really have to set up the systems correctly to make sure that there's actually some analysis done and not just things being pulled out of the hat, right? Like, one of the ways I often think of the AI, at least in the state it is right now, is like an overly eager intern that had a lot of coffee. Like this young guy with a bunch of coffee in his hands, and it's like, oh, you want to know how much revenue we made? Oh, we made 10 million. I'm so sure, So, like, that in mind, like, that's the AI as it stands right now, right? It's a people pleaser. It was trained on being really nice and good and like, so it's a people pleaser. And it's a lot of coffee, and there's no checks and balances.